Assalamu alaikum wa rahmatullah. This is data mining and warehousing, week 6 and 7, and we're going to discuss classification. Classification is considered to be your first introduction to machine learning. So what we've been doing so far has been about introduction to data and how to understand the data, and then how to pre-process the data in preparation for analysis. So starting this chapter, we're going to discuss machine learning, which is the actual analysis that we conduct on data. In this chapter, we're going to get to know what is classification and what is prediction and what is the differences between them. We're going to discuss issues regarding classification and prediction. And we're going to talk about classification by decision tree induction. This is going to be covered in this 2 hours. And in the next week, we're going to continue a bit about decision tree induction, and also we're going to talk about rule-based classification and discuss how to measure classification accuracy, and finally a summary. So classification versus prediction is actually depends on the type of data that we are predicting. So if you are predicting, now notice that classification and prediction are both prediction, okay? However, if you are predicting categorical data, then this is considered to be classification. But if you are predicting models of continuous values, in this case, we call it prediction. So classification, as I said, is to predict categorical data. And categorical data means that you want to predict if a certain tuple or record belongs to a certain class or belongs to a certain category. Yes, no, infected, not infected, student, not a student, female, male, etc. So we have a class that has we have, let's say, not a class, an attribute that has categorical values, and we want to know, or we want to use machine learning in order to see or in order to construct a model that can tell us if we provided with a certain tuple with all its information, it will tell us to which category does this tuple belong to. This will get clearer as we move on, as we see examples. Now, the classification or the classifier, as we call it, with data, it should be able to classify it based on the class labels. So what we do is that we create a training set that contains values for the classes, and we train the model. So the model will try to understand the different attributes and come up with and be able to automatically classify future tuples, even if they don't have classification, based on what we provided to it. Now, in the prediction, we were able to predict unknown or missing values of a continuous valued functions. This can be in terms of numbers, real numbers, integers. So it's a continuous value. It's not a categorical value. Now, to define classification, we can say that given a collection of records, and this is what we usually call a training set. So the training set will have records, and these records will consist of attributes. Usually we have one of these attributes that we call it a class, or sometimes we call it a label, because the class of this or this attribute, which is the class, is actually used to classify the record. Now, in order to do classification, we need to find a model for the class attribute. So we want to find a model for the class attribute so that we can use it as a function to using the other attributes in order to know how a certain tuple is classified as a certain classification. For instance, if we have a tuple of students and this tuple includes the student name, the student grades in all courses since they started, their GPA, and then we have a class attribute at the end classifying them as good student or bad student. So in the training set we will have multiple students with each one of them will have values for their attributes and a classification for the student. Now, if we construct a model, we will be constructing the model based on these attributes. So the model will study these attributes and will say, how did we determine that this student is a good student or a bad student? Now, what is our goal? Our goal is that if we successfully construct the model and provide the model with a student record or student tuple without its class, so its class is not, the student is not classified, the model will be able to successfully classify the student to be a good student or a bad student. Now, the set of records that do not have a classification, we usually call them the unseen records or the test data. And the records that are seen and are used by the model to learn about the data is called the seen data or the training set. So the goal is that for the previously unseen records, should be able to assign a class as accurately as possible. Now, we usually divide our data set into a training set and a test set, okay? And the training set is used to train the model to learn how to classify, and the test set is used to validate the model, to see if the model was successful in understanding, in learning how to classify the records. Now, this is an illustration of a classification task. So we will have training set and we will have a test set. If you notice, the training set and test set have the exact same attributes, filled exactly using the same data type. So if you notice how we have here transaction ID, attribute 1, attribute 2, attribute 3, and then we have a class. Now, in the training set, we have a classification for each of the records. So we already have a class. In the test set, we have all the attributes, but the class attribute is missing. Why? Because we want the model to be able to assign the correct class to each of these records. Now, the training set will be used in a method called induction for the model to learn. And the model or the learning algorithm that is used for the model to learn varies. And usually in any machine learning task, we apply multiple models. We try with multiple models until we find the most accurate and the fastest model. We do have, our measures of selecting which better model to use, but we normally test multiple models until we get the best. We identify the best between them. And we're going to learn some of the models that are commonly used. And today we're going to talk about decision tree, which is one of the learning algorithms that are used to create models, machine learning models. And we're also going to talk about other models in the future. Now, the learning model will be able to learn using the training set. And once the model has learned, we apply the model on the test set. And the process of applying the model on the test data is called deduction. Deduction meaning istintaj. We want the model to deduct, to istintaj, to find out what is the classification of each of these records based on how it trained previously. So classification is actually a two-step process. The first step is to construct the model, and the second step is to use the model. So the model construction actually is used to describe a set of predetermined classes. So we use the existing attributes to learn how to classify a certain record or a certain tuple into a certain classification. Now, this process actually mimics the human brain. This is how humans learn. They learn by examples, they learn by looking at multiple examples, and based on that, they will be able to classify. And they classify based on a set of attributes. Now, for each tuple, we used the already provided class. So we already have a class label for each tuple or for each sample or for each record. All of these are referring to the same thing: record, sample, or tuple. Now, the set of tuple that already has classes, we call them the training set. And the model that we apply on the training set is called a classifier. Okay, and this can be using classification rules, can be using decision trees, or we have also mathematical formula. We also have probabilistic approaches. So we have many types of models, and all of them are used to learn from existing attributes and from the training set. The second step is to use the model. So we use the model to classify unknown samples or unknown tuples or unknown records. So when using the model, we need to estimate its accuracy. How accurate was it in classifying the unseen data set? So the unseen data set, which is also the test set. Now, the known label of test sample is compared with the classifier result from the model. So we compare our results in order to calculate the accuracy rate. And the accuracy rate is actually a percentage. And this percentage, usually it means that it's going to be like 90%, 80%, 70%, 75%, etc. And we are usually aiming for a percentage that is higher than 85. So the higher is the better. We cannot go as 60% or 70%. This will be like a really bad accuracy level. So accuracy rate is a percentage of the percentage of test set samples that are correctly classified by the model. The percentage of test set samples that are correctly classified by the model. So hopefully that will be above 85%. It is important that the training set and the test set will be independent of each other. So they are not actually, they are not subsets. So you do not take part of the training set and say that this is going to be your test set. Otherwise, you will have an overfitting. And we're going to discuss overfitting further in details later on. Now, the classification process, we'll see two examples of a classification process. So the first step is the model construction. We have here a data set. This is the training data, and it includes the name, rank, years of experience, and tenured. Tenured meaning that it has a permanent job at the university or not. So it has it's a categorical data, yes or no, and this is our class. We want to be able to predict if a certain tuple is or a certain record is tenured or not. So it has two values, yes or no. Now the training data will go or will use a classification algorithm, so it will create a classifier, a model, and the model can look. This is an example of the model. This is a rule based, but it can be a decision tree, as we will see in a minute. So the classifier is saying that if rank equal professor or years more than 6, then tenured is yes. So based on this data, it found out that if the years is more than 6 and the rank is professor, then it's the value of tenured is yes. And if you notice, professor or years of experience is more than 6, then the value is yes. So here, professor, then it's yes. The rank, if it's assistant professor and above 6, if you see here 7 and 7, then it's also yes. Any other cases, it's no. So this is how the classifier will predict or will classify future tuples. Now, using the model to classify, so this is our scene data, okay? So we want to use, sorry, this is the unseen data. We want the classifier to use this test data to predict this data. Now it's unseen because this data did not go through the classification or through the learning phase. It's now going to be used in the classification phase to see if it's going to be able to predict correctly or not. So this is unseen data. Jeff, professor, 4. So this is the years of experience, and it predicted that it is yes because it's a professor. So this is the result of the classification, that yes, it's a professor, even though their years of experience is less than 6. Another example here, we have the training data. We have name, age, income, and loan decision. Okay, so age, we have youth, middle-aged, senior. Income, we have low, high, medium, and the loan decision can be risky or safe. So it is a categorical binary data, actually, because it can be either yes or no, so risky or safe. And we will use a classification algorithm, and this is also a classification rule that was generated by the classifier. If age equal youth, then loan decision is risky. And if you notice that always when it was youth, the decision is that the loan is going to be risky. So there is no case where youth was decided to be safe. Now, if income is high, okay, and then loan decision is safe. So no matter for the other types, which is middle-aged and senior, if the income is high, it's always going to be safe. If age is middle-aged and income is low, so middle-aged and income is low, then it's going to be risky. So this is what the model inducted. So this is what the model understood about from this training data. Now, using the model, we have this test data, and now we have this new data. We have John Henry, middle-aged and low. So using the classification model, the loan decision will be risky, based on the fact that it is middle-aged and he is middle-aged and low in income, then given the loan is risky. So in machine learning, we have supervised and unsupervised learning. Generally speaking, supervised learning is classification and supervised learning is clustering. All the examples that we were discussing since the beginning is actually supervised learning, because we have a training set, and this training set has a set of that has already been classified, and we're giving them to the algorithm to learn how to classify the data, to classify future records. So, however, we used to call, or what we discussed before, which is clustering. So, in this case, we do not provide the algorithm with labels. We give it the data, and we allow it to figure out different clusters for the data. And there are various techniques to do that. And these guide the model in order to find, or to come up with different classification for the data. Now, there are some issues with using with applying classification techniques. First of all, we have the problem of data preparation. We have to prepare the data before running the classification steps. So we need to make sure that our data is clean. We will reduce noise. We will handle missing data, and we will apply all the techniques that we discussed when we find problems with the data. We will also have to do a relevance analysis, which means that we're going to do a feature selection. We will see if we have attributes that are redundant, or attributes that are irrelevant and cannot be used in classifying the data. For instance, the name of in the previous example of deciding about a loan, the name of the person is irrelevant. It does not help with the classification. So we will need to remove it. We need to do data transformation if we want to discretize the data, or normalize the data, or generalize the data, so the classifier will be able to run it. Also, another issue is the evaluation of the classification method. So we apply then a classification method, and we need to know if or whether the classification method is accurate. So we want to know its predictive accuracy. We want to know the time the model needs in order to provide the results, because it's important. Sometimes the model can take too long in order to provide the results. And also the time to construct the model, the time we need to construct the model, and the time we need to use the model. Okay, we need to also be able to handle noisy data, to handle missing values. In the case of decision trees, we want to know or we want to decide how big can we go in branching the tree, how the size of the decision tree, and we will see regarding the size of the decision tree in a minute. Also, how compact are the classification rules? How are they able to represent all possible scenarios? And we will see that when we talk about classification rules. Now, generally speaking, when we want to measure the quality of the classification, we use the accuracy measure. And the accuracy measure is the number of correctly classified records over the total number of records in the data set. So we want to see how many were correctly classified, the ratio of how many correctly classified records to the total number of the test set, and this will show us how accurate the model is. Now, for the first hour, I will stop here, and we will continue in the second hour with decision tree as an example of a classification algorithm.